You know the feeling? We've all been there. A critical report is running super slow. Maybe a dashboard is timing out completely. And what's our first instinct? Just throw more hardware at the problem. More CPU, more memory, right? But what if the problem isn't the car itself, but the way we're driving it? Today, we're going to dive into how to fix the real source of most of those slow SQL queries.
So here's what we're going to cover. First, we'll talk about a super common mistake I like to call the scaling trap. And then we're getting right into 5 practical hands-on techniques you can use like today to speed up your SQL. We'll go from selecting smartly to filtering early, all the way to using something called CTEs. So let's just start with this. That little loading spinner is just mocking you, taunting you. What's your gut reaction? What's your first move? Are you immediately thinking about server settings, or are you looking at your own code?
And really, you've got 2 paths you can go down. There's the common fix, which is basically throwing money and resources at the problem, more hardware. But then there's the smart fix, writing better queries. It's all about using your brain to find the actual bottleneck in the code itself, not just buying a bigger engine.
This brings us straight to what we can call the scaling trap. It's this super tempting, but often totally misguided belief that more power is the only way to solve a performance problem.
I mean, this quote from Jaume Begunya just says it all, right? Adding more hardware should be your absolute last resort, not your first knee-jerk reaction.
And if you need a number to really drive this point home, get this, 80%. A huge majority of performance issues don't come from a slow machine, they come from inefficient code. And that right there is a massive opportunity for us to make things better.
Okay, so let's get into our first practical technique, selecting smartly. The concept is so simple. Don't go to a restaurant and order the entire menu when you just want a cup of coffee. You need to ask the database only for the data you're actually going to use. And here's a perfect example. On the left, we're doing a select asterisk. We're basically telling the database, hey, grab every single piece of information you have about these books. But on the right, we're being specific. We only want the title, author, and rating. The difference in the amount of work the database has to do is just enormous. And the benefits just cascade from there. You're pulling way less data from the disk, which means you're using less memory. That, in turn, makes any future joins cheaper. And you're sending way less data over the network. It's a win, 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 win.
Okay, our second technique is all about the order of your operations. The goal here is to make your dataset as small as possible as early as you can before you start doing any of the really heavy work, like aggregations or complex joins.
Just look at this comparison. On the left, we're doing the hard stuff first. We're telling the database to calculate the average rating for every single genre in the whole table. Only after all that work do we get our answer. But on the right, we do it the smart way. We filter for just the history books first, and then we do our calculation on that much smaller set of data.
Now there's a cool technical term for this, predicate pushdown. It sounds kind of fancy, but all it really means is you push your where clause, your filter, as early into the query as possible. This lets the database engine just throw away all the rows it doesn't need before it gets to the really expensive parts.
All right, technique number 3. Let's talk about indexes. Think of an index like a special lookup table that the database uses to find rows incredibly fast. It's kind of like the index in the back of a textbook. But, and this is a big but, they only work if you let them.
And this is such a classic mistake. On the left, by wrapping the genre column in a lower function, you're basically hiding it from the index. The database can't use its shortcut anymore, so it's forced to check every single row. On the right, though, we query the raw column, and that lets the index do its magic.
And the consequence of that mistake is a full table scan. That means the database has to read the entire table from start to finish. The analogy here is perfect. It's like going to a library, and instead of using the card catalog, you just start pulling out every single book off the shelf to find one sentence. It's crazy inefficient.
So, how do you even know if you're causing one of these full table scans? Well, that's where our 4th technique comes in. You need to ask the database what its plan is. You need to make the invisible visible, and you do that with the explain command.
Okay, so let's look at this output. This is the signature of an inefficient query. See how key is null and type is all? That's the database basically telling you, hey, I couldn't find an index to use, so I'm scanning all 10 rows. Now that's not so bad, but what if that number was 10 million?
And here it is. This is the aha moment. After we add an index on that genre column, just look at the plan. The key is now IDX genre. And
This is the crucial part. Look at the rows column. It's only scanning 3 rows instead of 10. We just told the database exactly where to look, and now it's orders of magnitude faster.
All right, let's bring it home with our final technique, using CTEs, or common table expressions. Now, don't let the names scare you. They're basically just temporary, named result sets that you can reference within a bigger query. They are a fantastic tool for cleaning up your code and stopping the database from doing the same work over and over.
So on the left, we've got a subquery. I mean, it works, but it can be kind of clunky and hard to read. And if you use that calculation multiple times, the database might recompute it every single time. But on the right, the CTE defines our scored result set just once, right at the top. It's clean, it's readable, and it's efficient.
And that's the real power of CTEs. They improved your code for both the machine and for other humans. The database avoids doing redundant work, and the next developer who has to look at your query, which, let's be honest, might just be you in 6 months, is going to thank you for the clarity.
So let's just recap everything. Here is your checklist. Number 1, be specific with your columns. Don't use select star. 2, filter early with where before you do things like group by. 3, let your indexes work. Avoid functions on those columns. 4, use explain to actually check what the database is doing. And 5, use CTEs to keep your logic clean and efficient. These 5 steps can solve the vast majority of your performance problems.
And that really brings us right back to our main idea. It's not about brute force. It's about being smart and making small targeted changes that can have a massive impact on performance.
So, I'll leave you with this question to think about. After seeing all these techniques, which slow query at your job or on your side project just popped into your head? You know the one I'm talking about. Go find it, run explain, and see what you can improve.